Hello friends, and welcome to yet another lecture on chemical engineering thermodynamics. What we'll be studying today? Let's have a look. Today we will be studying application of Gibbs phase rule to binary continuous distillation. I am Professor Arvind Prasad. Well, as we all know, and I have discussed this in many of the videos which should be available in the playlist, that the Gibbs phase rule for non-reacting mixtures is F is equal to C minus P plus 2. That is, C is the components, P is the phases, and 2 is 2. Now, there we are. Let's apply this to a binary continuous distillation problem. In a binary continuous distillation, what we have is a binary feed which goes into a distillation column, and this is the feed tray. And then we have the bottoms and we have the top product, that is the distillate. Now, in a binary distillation column, the distillation happens at a constant pressure. Even though there is pressure drop in the column, you need to understand one thing, that if there is pressure drop, there is a constant pressure across or on every plate. So essentially the distillation on any plate happens at constant pressure. Now, if we apply the Gibbs phase rule, we have two components. So we have 2 here and we have 2 phases, because what happens on every plate is the vapor phase or the vapor leaves in equilibrium with the liquid. The vapor leaves in equilibrium with the liquid. So we have 2 phases, so that is 2, and 2 minus 2 plus 2 makes it 2. Now, since the pressure is constant, one of the degrees of freedom is fixed, that is, pressure now is fixed. Now, the second degree of freedom, that is the concentration of the liquid leaving on every plate. If we take that as the second degree of freedom, then rest all variables or state variables get fixed automatically. Now, we need to understand here that once we have fixed the concentration of the liquid leaving any plate, then the concentration of the vapor or the concentration of the ith component leaving in the vapor is automatically fixed by rules of equilibrium. Therefore, we can say that each and every plate has a unique temperature, because one of the degrees of freedom taken away is the pressure. The second degree of freedom taken away is the concentration of the ith component. I can be any component, it can be x1 or it can be x2. That if we fix, then the temperature on the tray is fixed. Now, what is the consequence of this? The consequence of this is that the temperature when the distillation column is in steady state, running in steady state, the temperature on each tray now is fixed. Like in temperature, the temperature in plate number 1 is T1 and that in plate number 5 is T5. As I said, the concentration is fixed, therefore X1 is fixed and Y1 is fixed on T2 by rules of equilibrium. So, when a column is running in steady state, we have a steady temperature on each and every tray. Now, this helps us in controlling the distillation column. Why? Because if we know the temperature profile, this automatically means that we know the concentration profile. Why? Because now temperature is related to concentration. And therefore, if the temperature profile is right, it means the distillation column has been set up properly. That is, the liquid and the vapor flow rates or the reflux ratios have been set right. Now, if there is any disturbance caused in the distillation column, the first effect it will have is on the concentration, which automatically means it will have effect on the temperature of the trays. And if we read the temperature of the trays and they are not as per what it was designed for, it means that the column is not running properly and it has been disturbed. Here we have seen that how Gibbs phase rule allows us in understanding the entire process of distillation and controlling it. That's the end of my lecture. Hope you have understood something professionally. This lecture was specially targeted for students, but it was targeted for professionals too, because many professionals, while designing, do not understand this feature, do not apply the Gibbs phase rule, and over define the systems while designing it or while making a controlled scheme for it. Hope you have understood something from this lecture, and please like and subscribe my channel and my videos. Watch them, enrich yourself in chemical engineering. Have a great day, guys.